Hello, my name is Rachel White, and I'm from California State University, East Bay, where I am working towards my Bachelor's of Science in Chemistry. And thanks to the summer program, I was able to work with Dr. Martha Chacon on a project identifying PFAS in microplastics in food packaging using mass spectrometry. Many people nowadays are aware of plastics' environmental damage to the ocean's ecosystem. These plastics often break down to smaller and smaller pieces known as microplastics and can be consumed by the smallest of fishes all the way up to the biggest of mammals in the water, such as whales, which can cause a variety of health issues for the animals that consume them. However, fewer people are aware of the microplastics and chemicals that they consume daily from food packaging. Plastics are primarily made of polymers, which are compounds composed of repeating units, and PFAS are a large category of chemicals that contain multiple fluorine atoms. People will end up consuming microplastics and PFAS due to them leaching and getting absorbed into their food. My project focuses on identifying the potential microplastics and PFAS chemicals that have been leached from common food packaging by analyzing the leachates with fluoral transform ion cyclotron resonance mass spectrometry coupled with electrospray ionization. We attempted to subject each food packaging material to similar conditions to how they would be used in everyday life. The plastic tea bags were boiled in hot water, and the cooking liner, these cooking bags, and the disposable coffee cups had hot or boiling water poured inside. We could not properly simulate the use of sandwich bags and popcorn bags, so we opted to do a salts extraction to extract any potential PFAS that could be in the samples. The water from the samples were then dried under nitrogen and then redissolved in methanol to be analyzed in the 21T FTICR. The thousands of peaks generated through this analysis then get assigned unique in order to see what type of stuff is in the samples. Here we can see a mass spectrum of the species leached from tea bags that were boiled in water. There are over 1,000 peaks, each representing a unique molecular formula. Each of these spectrums can be analyzed by looking for patterns such as consistent peak difference and using software to help determine molecular formulas and visualize the relationship between the carbons and the double bond equivalents. As you can see in the graph, there is an increase in DVE of 1 and an increase of number of carbons of 6 for the slanted line. And you can see in the graph that there is a mass over charge difference of 113.084. This correlates to the plastic nylon 6. And that has basically the same molar mass in DBE as the graph, and difference in charge difference. We were also able to identify that the slow cooker lining contained fluorinated species suspected of being a type of PFAS, while the disposable coffee cups were also most likely lined with nylon 6. Due to the limited time of the program, aspects of the project could not be finished, such as not all the materials were analyzed, like the second pair of sandwich bags, and an experiment trying to simulate a popcorn bags in like a microwave environment was also not done. I would like to thank Dr. Chacon and Joseph Fry for helping me with my analyzing and teaching me all about mass spectrometry. And I would also like to thank the REU program for giving me this opportunity. Thank you.